probably have many questions about color blindness, but the question we are going to answer first is, what is color blindness? Color blindness, which is also called color vision deficiency, is a reduced ability to distinguish between certain colors. Many people mistake color blindness for seeing the world in black and white, but instead of seeing the world like this, people who are colorblind actually see the world like this. Color is determined by the wavelength of a stream of light. Wavelength is the distance between two similar points on a wave. The human eye has 3 types of cone cells that each detects a certain range of wavelengths and therefore a certain color. The L cone detects long wavelengths and therefore reds, the M cone detects medium wavelengths and therefore greens, and the S cone detects short wavelengths and therefore blues. The combination of the signals the brain receives from each cone cell lets it determine what color it is seeing, so when a cone is damaged or absent, the brain confuses the color it is seeing. There are also different kinds of color blindness because people who have color vision deficiency could have a combination of their cones damaged. The most common form of color deficiency is the confusion of red and green or the damage of the L and N cones. Color blindness is not very common, but when it does occur, it is more likely to occur in males than females. In fact, only 8% of males are colorblind, but less than 1% of females are colorblind. Color blindness is hereditary, but there are other ways of becoming colorblind, such as aging, alcoholism, side effects of medicine, and accidents that result in the damage of the eye. To further understand how color blindness affects vision, you must first understand how color works and therefore how waves work. There are 2 types of waves: electromagnetic, which do not require a medium to travel, and mechanical, which do require a medium to travel. The color of an object is actually the wavelength of the reflected light bouncing off the object, while all the other light is absorbed. Reflection is the bouncing back of waves, while absorption is the opposite, or the process of containing the waves. When the wave is reflected, the cones in the eye detect the wavelength and then determine what color it is seeing based on the ratio between the cones. Because light travels in electromagnetic waves, the colors we see are located on the electromagnetic spectrum, which is a scale of electromagnetic waves that spans from radio waves to gamma rays. Color is located in the visible light category on the scale, which simply means that humans can see it. However, as we have discussed, not all humans see the light the same way.
Created using Powtoon.